All right, good morning, everyone. How did the homework go? Do you guys have any questions about the homework I assigned for today?
You mean the math lab or the other stuff?
They should be very much the same. So ask any questions you want, go ahead.
Number 70.
So as I said, the way I'm doing it, I'm trying to assign the same problem from my lab and from the book. There will be very small variation. So like if the book have 9, my lab will have like 6. That's about the variation that's happening, which is actually good for you. So once you know how to do it, you can do it on my lab. So let's look at number 70 and working with difference quotient. So we have the following function. F of x equal 4 minus 4x minus x squared.
Oh, balls.
And questions? And the question is the following. They want us to simplify the following quotient. F of x minus f of a over x minus a. Okay, so let's do that. Okay. And then we're gonna try to visualize this geometrically. It means this difference quotient, how can we really visualize it in terms of the function? First, let us do the math. Okay, what is f of x? F of x is nothing more than the value of the function at x minus f of a is 4 minus 4a minus a squared. Sorry. And the whole thing over x minus a. So we set it up. And now we just basically simplify. Give me 4 minus 4x minus x squared minus 4 minus minus plus 4a minus minus plus a squared over the quantity x minus a. Now I see if I can like simplify terms. Usually plus 4 minus 4, they can simplify. Anything else? Anybody see anything else I can simplify? Doesn't seem like it. So let's see what we get. X minus a here. And then I'm gonna get like a squared, so if I put this in the beginning, minus x squared, and then minus 4x plus 4a. Okay?
In my lab, they actually simplified it further, I believe.
Yeah, I know.
Yeah, okay, all right.
Yeah. That's what I was expecting you had difficulties with. So how did my lab simplify? All right. The idea to simplify, they have to factor a little bit. So let me show you how they're going to be factoring. Unless anybody like to give us an idea. Anybody was able to factor this, to simplify this further? Anyone?
Not until looking at the example.
What? Okay, the way we're going to factor it is like that. This expression here, okay? And this expression here, a squared minus x squared. How can I factor it? Anybody remember? That's the difference between squares. How it would be factored?
X
A
minus
plus X.
A minus x.
A plus X.
A plus x. Very good. Okay, so this is a factorization that we should always basically know that if you take the quantity a minus x, you multiply it by the quantity a plus x, and you actually, sorry.
You're muted.
Okay. Right here, I'm going to factor out the 4, and what I will be left with? I will be left with minus x plus a minus x plus a. Okay. And this will be x minus a. Now I am almost there, and almost, not quite, but it's almost there. So let's do that, what I will have here. So anybody start seeing anything? Anybody start seeing anything? Watch carefully. A minus x. And this is also a minus x, right? This is minus x plus a is the same thing as a minus x. So I have a minus x from here. I can actually do that now. I can factor out the quantity a minus x. And doing so, what I will be left with? Here, I will be left with a plus x. Okay, and here I will be left with a 4. Any questions as I move on? Now, what else can I do? What else can I do? This is pure algebra at this stage. What else can I do? This is a minus x, and this is x minus a. So
Factor out a negative.
we have to draw a negative, right, because I have x minus a, I have a minus x. So I'm going to write this as minus that. And am I right? Is this and this the same? Minus x, minus minus plus a, absolutely that. But the reason I did it because I want to simplify x minus a, x minus a. Now, those simplified, and the answer would be minus the quantity a plus x plus 4. All right? So it's a little bit of algebra. Okay, so the setup is not hard in this problem. It's the algebra, which is a little bit tricky. Okay, questions? Make sense? All right. Now, a small comment before I proceed. Let us a little bit interpret this difference quotient graphically. So I will rewrite the function. So my function was, let me rewrite it, 4 minus 4x minus x squared. And the difference quotient they want us is that. Okay, what did we call this difference quotient yesterday? What did we call it? We gave it another name. What this was called?
Average rate of change.
That's the average rate of change. We call this the average rate of change on the interval, let's write it XA, on this interval. So graphically, what does this quotient represent? Graphically, it represents the following. If I sketch the graph of the following function, this one. So this is the graph of 4 minus 4x minus x squared. And I will not graph it exactly, but intuitively, we know that this is a parabola. This is a parabola going basically down because of the minus in here. And the intercept, if x is 0, this is equal to 4. And so, and it's going to look something like that. Give and take a stupid mistake, but that's not the point. So it's going to look something like that. All right. What does the difference quotient represent? It represents the following. If I take, this is the point, let me fix this and let me call this is x, for example. And let me call this A. So we're trying to visualize the difference quotient graphically. What is this? Actually, I want to change them. This is A and this is X. Sorry, this is A and this is X. What's the difference quotient? It's f of X minus f of A. What is f of X minus f of A? This is right here. If this is X, this is f of X. If I call this A, this is f of A. So f of X minus f of A is nothing more than the change in Y from here to here. Or the way we visualize it, this is f of X minus f of A. So this picture, we will be going over it over and over because it's extremely important for us. And what's X minus A? X minus A is from here to here because this is X. You take away A from it, this is X minus A. Or this is X minus A, which is the change in X. So the difference quotient is the rise from here to here over the run from here to here. So the difference quotient is nothing more than the slope of this line. It's nothing more than the slope of the secant line. So the slope of the secant line, the slope of the secant line is this quotient. Okay, so that's how we visualize this graphically. All right, now somebody is asking to look at number 41 and then we proceed for the new lecture. So number 41. Okay, let's see what is it about very quickly. Okay, composite function. So we have f of X equal X squared minus 4. And the question is to simplify f of the expression x plus 4. Okay, all right. What is f of the square root of that? So, okay, so now what does f do? It takes an input x and it does something to it. Whatever you give it, it squares it and then takes 4 away from it. So what is this going to be? This is now what you input. So you take what you input, you square minus 4. Now your input here is the square root of x plus 4. Okay, but what's the square root of x plus 4? If you take the square root of something and you square it, by definition, that's the x plus 4. Minus 4, this is x. All right? Any question before we proceed? Except those on the chat that I will not answer right now. I'll answer later. All right? Very good. So today we're going to move to section 1.2, which is actually always is the same. We're still doing a preview for pre-calculus, which is going to like last a little bit. So now we're going to study formulas for function, if you want. So how a function is given to us. So we already discussed, function given to us by a graph, by a table, by a formula. And now we're going to emphasize specific function, like linear function, piecewise defined function, exponential, logarithmic, and so on and so forth. So for the first few minutes, I will review very quickly with you because usually you should have no issue with that. Linear function. Okay, that's very quick review. So what is a linear function, at least for now? So linear function is simply a function whose graph is a line, okay? So linear function is a function. So it's a rule. When you sketch the graph, you get a line. It's a function whose graph is a line. Is a line. And usually the formula for the linear function is, that's the formula. It has the following form. So if you have a function, and you graph it, you get a line. So what's the formula? It means what's the form of the formula that if you know x, you can find the output f of x. So as you all know, usually the formula is the slope times x plus b. Okay, stuff you've seen since middle school. So let us very quickly, I'm going to take a graph and let us say I take the following graph. And the question is, find the formula for the function given by the given graph. So find the formula for this function, for the function given by the graph. Okay. Right, so in other words, I have a function. I give you the graph, which is a simple line, it's linear, and I'm going to give you 2 points on the graph, and very quickly we will find the formula. So let me take, for example, this is 1 point, 1, 4, very easy. And then I'm gonna take another point, which is 4, 10. Very quick review. And the question is, find a formula for f. All right, so all of you, how do we find a formula? First, we need to find the slope. So I will do it 2 ways. I will do this problem 2 ways, and I will tell you which one is my favorite. Okay, so first we need to find the slope that we usually call m. So what is the slope here? Okay, the slope is the change in y, 10 minus 4. So that's what you would call the rise if you want, or the change in y, divided by the change in x, which is 4 minus 1. So my slope in this very, very simple problem, that's it 6, that's a 6 over 3, which is giving me a 2. So this is the slope of this line, which is basically the average rate of change of the function. And if a function is linear, the average rate of change is constant, because the average rate of change is nothing more than the slope of the line, which is constant for a linear function. So what's the formula now? So if this is the slope, it means the function has the form 2x plus b, as you guys know. Now I need my b. We use a point, so we say the point 1, 4 on the line. It means the function should take 1 to 4. That's what the function should do. So this will allow me to find the b. So it means if I take 2 plus b equal to 4, it means my b has to be equal to 2. And this function is given by the formula 2x plus 2. Okay, so it means that now if I have an x, any x, and I want to find the output, it's very easy. I just plug it inside the formula. What is f of 3? 2 times 3, 6 plus 2, 8. So this gives me a formula. Now another way to can find the formula for a linear function that we will eventually, the one we will be using, is to use what we call the point slope form. So another way is using the point slope form. And as I said, this would be the way I would like to find equation for a linear function. So another way, the point slope form. And what does this point slope form tell us? If you guys have any, you should have, of course you should remember it. It tells me the following. So if you have a point on the line, so x0 point on the line, and m is the slope. Then to find a formula for the function, you use the point slope form, which is, you guys remember it? Y minus y0 equal the slope x minus x0. Okay, very useful, and it's my preferred way to find equation of a line. All right, so now I go back to my problem and I will use it again. So now this is my simple function here. And it has those 2 points, 1, 4, that's 1. And this was, if my memory, that was 4, 10. So we will find again the equation of the linear function given by this graph. using the point slope. So M, we already found it. It is the change in Y. So as we go from x equal 1 to x equal to 4, Y rose. It was, the output was 4, the output was 10, so it's 10. So the change here was 6 divided by 3. Now I'm going to use the formula, so that's the slope. Now I used either point. 1, 4 is a point on my function. So the equation would be y minus 4 equal the slope x minus 1. Now we simplify a tiny bit. 2x minus 2, and y is 2x plus 2. What's what we expected. So in a function notation, so it means that if I know the x here, I know the y. So in function notation, we write f of x equal to x plus 2. All right, so this is a linear function. It's easy to find a formula for them. They represent function where the average rate of change is constant. It means function where things change at the constant rate. They don't really change at different rate over time. The second type of function we are going to study today is piecewise defined function. So what's piecewise defined function? Okay, so let's see definition. And then we work a lot of examples. What's a piecewise defined function? They are functions that have different formulas on different part of their domain. So they are functions, but the formula change with x. So we don't have a unique formula for all x's. Like when we took the following problem, f of x equal, let us say 4 minus. Okay, so this was the formula for all x's. Piecewise, it means the formula change with x. So before we start really studying them, do they occur? So the typical example of a piecewise is something like that. Think of the taxes. Taxes as a function of the yearly income. So you know when your income changes, of course, your tax change. But how does the tax work? So suppose I have the following. I'm gonna graph a little bit the tax. So here x, the input, is yearly income. That's the yearly income. And the output is the tax you pay for this yearly income. So how does really the tax work intuitively? So, okay, if you make less than really a certain amount, you probably don't pay much taxes. Okay, let us say under 30,000. And then how does the tax go? If you start making a little bit over that, then you start paying taxes. And how the tax go? The tax at this stage jumps. So now you start paying taxes, and it is linear. It means it's a certain percentage of your income. So it is linear. Like this. Okay, like 15%. Up to a certain amount. Let us say up to 30,000 you don't pay, up to 70,000 or 100,000, it's 15%. If you pay, if your yearly income is more than 100,000, then again, the tax is going to increase, but it could be steeper because you're going to pay a higher percentage of your income. So now the graph is going to be, it's going to become steeper. Okay, so the formula for the taxes is really depend on the domain. If your x between 0 and 3,000, that's how much you pay. Between 30 and 100, that's how much you pay. Between 100 and 1,000, you have a totally different formula. So that's really where the piecewise idea comes from. It means your output, the formula for the output really changes with the formula for your input. Right, so let us now take a function and start to know how to read them, and then how to graph them, and then how to actually find a formula for them. So example number 1, just to familiarize ourselves. I'm going to ask you several questions, and please you answer. Suppose this is a function. Usually that's the graph of the piecewise defined function. It's piece by piece. It's not like one graph. It's really kind of pieces. And let us at least familiarize ourselves with how to read this. So I'm going to ask you simple questions. I hope this graph is clear for you. Very simple question. What is f of, which one I want? Anything actually. Let us say, what is f of minus 2? Very simple. Okay, you guys see the picture. What's f of minus 2? This is minus 2 on my graph. Yes, it's 4. So we go all the way up here is equal to 4. Okay. Now, what is the only one I care about is actually what is f of minus 1? What is f of minus 1? This is minus 1. All right. What's f of minus 1? If you go this way, there is a closed circle and an open circle. The value of f at minus 1 is actually what happened at the full circle. It's the value right there. It's not what happened at the open circle. So f of minus 1 is somewhere in here. And somewhere in here, that's 1, 2, 3 is almost 3.5. It means the function, the value the function obtained at minus 1 is what happened at the full circle, not at the open circle. Before we move on, suppose a student or whatever, you see a picture that had a full circle here, a full circle here. Any comment you can make? Is it possible for the graph of a function to have two full circles? Yes,
No.
Absolutely not possible, because if it has two full circles, it means at minus 1, it has two different outputs, which is absolutely nonsense. A function cannot have two different outputs. So whenever you have a function given piecewise and there is a jump, one of the points will be closed and another one will have to be open. The function cannot have two different values at the same point. Right? So that's really how the graph of piecewise defined functions are. Now we're gonna do two things today. First, we will show how a piecewise is given by a formula. We're gonna graph it. And the second is how to find a formula for a function when you have the graph. So the first one I will do is the following. Suppose you have a function. And this function is given by the following rule. If the input less or equal to 3, the output is 2x minus 1. That's the rule. If your input is larger than 3, your output is 4. So the output, there is not a unique formula for the whole thing. The formula depends on where x is. So let us try reading this very, very slowly. So suppose I ask you the following. What is the output at minus 1? Okay. The first thing you do is you take minus 1 and you ask yourself, which condition does minus 1 satisfy? Does it satisfy this condition or that condition? It depends. Minus 1 is less than 3. So the value of the function at minus 1 is given by this formula. So what is f of minus 1? It's 2 times minus 1 minus 1. Because at minus 1, my input is less than 3. That's the formula I use. So this would give me minus 2 minus 1. This will give me minus 3. Very good. Now, what about f of 4? Again, what is f of 4? I go and ask myself which condition, which domain is 4. It's not less than 3 or is larger than 3. What's the output? If something is larger than 3, the output is 4. So we are trying to read it first. Now, what is f of 3? Okay, f of 3. Okay, which condition satisfied? The condition it satisfies is this one. So the output at 3 follow this formula. It means 2 times 3 minus 1. It means 6 minus 1, which is equal to 5. So that's how we read piecewise defined function. Now, the second question is, we want to sketch the graph. Means how can I graph something that reflect this formula? So we take another piece of paper and we do that. So I will write the function again and I will work on the graph. So let us see. 2x minus 1, x less or equal to 3. I'm just rewriting it. And x bigger than 3. All right. So let's graph it. Can I move on? Okay. So let us do that. I will do it very slowly. I will do the first one very slowly. So this is my graph right there. Okay. And how we are going to graph this function. The output depends absolutely on the input. So this is 3, my 3 right here. And up to 3, there is one rule. After 3, there is another rule. So let me first graph this function for x less than 3. So on this side, let us say on this side. And then I will copy back into the function. So before I even hit this function, suppose I ask you to graph y equal to x minus 1. Okay, this line. How would you graph it? So on the side now, that's what you guys will do. On the side, what is y equal to x minus 1? That's a line, right? So if I want to graph this, I graph a line. How do I graph a line? Okay, graphing a line means you need 2 points on the line. So let us draw 2 points. So the usual point, always we'd like to know what happened at 0. And I'm going to pick my 2 point less than 3 because I would want to graph this for x less than 3. If x is 0, y is minus 1. And if x is 3, y is 2 times it equal to 5. So if I ask you to sketch the line y equal to x minus 1 for the now, it's not hard. Tell me, this is a line. At 0, it's minus 1. And then at 3, it takes the value 5. So this is the line. That's the line you get. Now, how I'm going to transfer this information to that? But this is telling me that the output is this line up to 3. It means I'm going to draw this line, but stop at 3, because that's how my function is defined up to 3. So let's go back and draw the line back here. So what I'm doing is, first, I want to draw this piece. This piece by itself is a line. So is a line x to x minus 1. So I want to draw it, I need 2 points. And I pick both my point in this domain. So 0, minus 1, 3, 5. And now I graph. Minus 1 is down here. 5 is up here. And 3, 5. This one is going to be, we're going to discuss it. And then how does the function looks like? It's a line. Sorry. My line is not straight. I should use a pencil because I don't want to do a mistake. So it's a line, a straight, honest to goodness line. A line, but I stop the line at 3. And 3 is included here because if x equal to 3, my output is 5. So this is the first piece of my graph. So this is the piece, if you want, to x minus 1. I stop it at 3. After 3, what's happening? If x larger than 3, my function takes the value 4. So at 4, it takes 4. At 5, it takes 4. So let us assume this is 4. After 3, now 3, it doesn't take 4. So I'm going to open it here. And then it takes 4. So that's the graph of my function. So we do it piece by piece. We sketch the graph of the line to x minus 1 up to 3. Done. And then I pick up another piece. I sketch the graph f of x equal 4 for x bigger than 3. And then if I have more pieces, I will do the same thing. All right? So let me pick up another problem. along the same line. Okay, this is my problem again. And we will do the first part together. Then I'm gonna give you a few minutes. You guys take a scratch piece of paper with you and try to graph it yourself. I'll give you a few minutes to do that, and then I will show it to you on the board. But I meant on the document camera. But first, let us make sure we all know how to compute f of minus 1. So what is f of minus 1? I want on the chat to tell me the answer. On the chat, what is f of minus 1? Anybody? I don't see answers. 5, everybody tell me 5. Okay, are they correct? What is minus 1? Minus 1 is less than 0. So which formula apply? The first formula. So it's 3 minus 2 times minus 1. Everybody is correct. F of 0, quickly. 0, because 0 is in here. F of 0 is 0. Very good. Now, what's f of 1? F of 1, look, Elizabeth, 2. Because where is 1? 1 is in this piece between 0 and 2. So it's 2 times 1. And f of 2. What is f of 2 very quickly? 4. Very nice. It's a 4. And what is f of 4 finally? F of 4 minus 4 plus 6, 2. Yes. Absolutely correct. Now sketch. And now I'm going to let you a little bit spend some time. So I'll give you 3 minutes to see how well you guys can do with sketching the graph. Try to sketch it the way I'm doing it. You're going to have 3 pieces. Each one is a line. Each one is a line. And then we're going to put lines together. That's really what is it about. Oh, sorry. Okay. Please, if I ask you to do something, do it. That's the only way, you know, we can learn this stuff. Okay. I'll give you 1 more minute and then I'll do it and you guys check if you've done it correctly or not. Please, when I ask you to do something, please do it. I want all of you to do it. You know, that's the only way you're gonna learn. Minus 1, minus 2, minus 3. Okay, let's see. Let's see if you guys got it correct. So you guys check yourself. So the first piece, 3 minus 2x. And this piece goes up to 0. So I'm gonna sketch the first piece of the function. 3 minus 2x, we know that when you graph this, you get a straight line. So to sketch this piece, so that's the piece, I need 2 points. So let's see 2 points. X, 3 minus 2x. I pick 2 points which are less than 0. I pick -1, which is 5. And I usually like to pick 0 because it guides me, but I know that the function doesn't take the value I will pick at 0, but it's actually guide us a little bit. So at 0, the function will take 3. And I know we're gonna have open circle here because 0 is not included. So let us draw the line. At -1, this is -1. My function takes the value 5. So that's a point on the line. At 0, it should have taken 3, but it's gonna be, so this is my 5, this is a 3. That's gonna be an open one. That's open here. So my line, I draw the line, and I'm going to stop right here. That's the first piece. So this is the piece 3 minus 2x. That's my first piece. Done. Now I'm going to pick up the second piece, y equal to x. That's again between 0 and 2. That's again a straight line. So let's do that. So I need 2 points, x to x. At 0, it is 0 and this is included. So we know that this is closed and this one is going to be open. And at 2, it's not included for now, and this is 4. So at this is this point, so this was 4. So I'm going to go up here and up here. And for now, I'm going to open it because 2 is not, and that's a straight line. Remember, the graph should be a function, so we should be very careful with it. So I'm going to just change this one a little bit to make sure you see it as open. Yeah. Now it's clear open. Very good. Now, I took care of this piece. So this line here represents y equal to x, the second piece of the graph. Now finally, I have the last piece of the graph. So the last piece is, now I want to take care of that. Minus x plus 6. So again, this is a line, straight line. I need 2 input, 2 points. I always pick the 2, which is going to give me a 4. And I'll pick something else. That I pick 6, for example, it gives me a 0. So at 2, it's 4. Now, what's going to happen at 2? What's going to happen at 2 is that this open circle, I have to close it again. Okay, why? Because at 2, my function is actually taking the value 4 due to this formula from here. So even though I opened it before because I was doing this piece, now I am forced to close it because that's the actual value at 2. That's what I pick up from the last piece. And then at 6, somewhere in here, the function takes the value 0, so I'm going to have the straight line. And this last piece is the graph of minus x plus 6. Okay, so that's how we will be sketching graphs of piecewise defined function. So for those who got it correctly, great. For those who didn't, I hope you understood your mistake. Okay. Now, the last thing we're going to do today is the following. I'm basically going to go backwards. It means if I gave you a graph, how can you write the formula? So what we're going to do is backward. I give you this, you have to give me the formula. And it's not really actually hard. So that will be the last example we will be doing. So, all right, this is my graph. Okay, and the question is, find a formula whose graph is given below. So how can I find a formula? So the formula is going to be something like that. It's going to be something like this. One formula, another one, and another one. That's how the function will be given. So how we are going to find the pieces. Now, if you look at the graph, what's really going on? Okay, this is -1, right? This is -1. It seems to me that up to -1, I have one formula because the output is what happened on this line. Between -1, that's 1, that's it, 2. I have another formula, it seems to me. And from 2 and so on, we have a third formula. So that's the picture tells me that's what's going to happen. And we have to find every piece. So let's see how my function is going to look like. So I will write here, and then we figure out. So my function is going to be a certain formula when x is less or equal to -1. That's what the picture suggests. Between -1 and 2, open at -1, close at 2, we're going to have something else. And finally, for x bigger or equal to 2, we're going to have another formula. So let us find every piece by itself. All right, this one, I'm going to call this line L1, for example. I just call it L1. I want to find the formula for the function up to -1. What really boils down to is find the equation of this line. So if I know the equation of the line L1, I basically know if I have an x in here, what should be the output. So really finding it is really boiling down to finding the equation of the line L1. Now, do we know how to find the equation of the line L1? How can you find the equation of the line? So let us find equation of L1. Because if I know the equation, it means I know the output given the input. So how to find the equation of a line? You know, we need 2 points. If I have 2 points, I find the equation. All right, who can give me 2 points on the line L1? Who can give me 2 points? The easiest possible point that you can think of on this line, the easiest one. -2, 4, I like that because there is no fraction. So -2, 4, that's a point. Who can give me another point on the line L1? -4, 5, -4, 5, I think those are great points. -4, 5 is another point. I have 2 points, I have the equation. So let us do that very quickly. What's gonna be the equation? Okay, we find the slope, which is 5 minus 4, the change in y, over the change here. So it's gonna give me -1/2. And I know the slope is negative because the line L1 is actually going down. So now let's find the equation. And as I said, you can use, I will use the point slope form because I want you to get used to it. That's the one I will use the most in this class. So let me use the point slope form. I pick any point. Suppose I pick that point. It doesn't matter which one you pick. It's going to be y minus y0. That's the point I'm choosing. Equal -1/2 x minus x0. Since this is a negative number, it's going to be +4. So the equation would be equal -1/2 x minus 2. And now I combine things. So it means, so that's, I'm still with the first 9. It means y equal -1/2 x plus 3. That's give me the equation of the line L1. What does it mean for us? What it means for us is the following. If x is less or equal to -1, the output are -1/2 x plus 3. That's really what it means to us. So if, let us say, I pick x to be -2, x to be -2, I will have, according to the picture, I'll have 4, and also according to my formula, because if I plug in -2 in here, I will have a 1, because -2 times -1/2 is +1, plus 3, which is 4. So this formula reflects L1. Now, I'm going to find equation of L2, and this will give me the formula for that. So to find the equation of L2, I will do it here because so you can see the screen very well. Equation of L2. Again, I will use the same idea. L2 is a straight line. To find the equation, I need 2 points. So all of you, give me the 2 points. 0 minus 3. Okay, let me see. 0 minus 3. Absolutely correct. So 0 minus 3. Who want to give me another point on this line? 1, 0. I'll pick this one. 1, 0. The students are giving me that point. Absolutely correct. Now, very simple. I find the slope, which is the change in y, 0 minus, which is a 3, 1. So the slope is 3. and I can use the point slope form, and I will get, actually, since I have the intercept, this is going to be 3x minus 3. That will be the formula. So now in function notation, it means between -1 and 2, the output is given by this formula. So as you realize, it's not really very hard. We can actually ourselves. Now, so I have the piece between -1 and 2, that's the output. So if I take any x between -1 and 2, and I want the output, I can either plug it inside the formula, or I can look it up in the graph here. We should have exactly the same thing. Now the last piece, if x is bigger or equal to 2, what is the function? So right here, what's gonna be the output? So up here, the function is constant, right? The function is constant, y equal to 3. And if I take this value here, it's 3. It means if I give you anything bigger than 2, I tell what's the output, you tell me it's 3, it's 3, it's 3, it's 3. It means my function is equal to 3. And that's the formula that corresponds to the graph. So we can go from the graph to the formula, or we can go backward from the formula back to the graph for piecewise defined function. Okay, right? I finish with this note. For tomorrow, of course, you guys will have your homework as usual. Please make sure you do it. You have to do it, and you will have a quiz. Tomorrow will be our first quiz, and I probably, of course, tomorrow I will guide you of you know, where to get the quiz from and how to do it. The main thing that you guys should be able to do, which is, of course, I cannot help you, is you should know how to upload your quiz into something. So the way you will do it is that I will put the quiz on Brightspace. You guys download it, or you can just open the folder and take a nice piece of paper, write your homework, the quiz on it, the answers on it. If you happen to have a printer, it will be nice if you can print the quiz and write on it, but I cannot force you to have a printer. And then once you're done, you will have to upload it into Brightspace. So you can either scan it if you have a scanner and upload it. If you don't have a scanner, okay, you have to take a good picture of it and then upload it into Brightspace. Okay, so tomorrow I will give you a lot of time. Just a second. I will give you enough time tomorrow so you will be able to, you know, adjust the system. And after that, I will not give you a lot of time. So once you learn how to do it, we will be fine. Okay.
Would we be able to email the answers?
No,
or does it have to be through Brightspace?
no, it has to be. I tell you honestly why, because I have a lot of students, whether in your class or other classes. There is no way I can keep track. You know, if every student, you know, start doing this, it's impossible for me to keep track. All right. Did I answer your questions? Okay, any other questions? One student asked me about posting the notes. I'm posting the whole lecture. So I will not post the notes. Okay, so you listen to the lecture and start taking, you know, notes yourself, which will be very helpful. Very good. I mean, you guys are helping each other very well. Would we be doing during the time? Would we be doing it during the time of class? Yes, we will be taking the quiz during the time in class. So tomorrow, the last 20 minutes, and probably tomorrow I will take longer because it's for you to adjust to the system. Yes, we'll be taking them during the class. I will be with you. It will be timed, so you will not have forever. And if you have any questions during the quiz, it's like today. You guys can you can send me a comment on chat, and I can answer your questions. So if let's say I have a typo on the spot, I can fix it. Yes, go ahead.
I have a class that starts at 9 tomorrow.
You have a class that starts at 9. Anybody else have a class that starts at 9?
Well,
okay, all right.
Not a class, but I gotta be to work at 9.
You have.
Yep. Same.
Oh my goodness. Okay, I will think about that. You guys will be fine. Is that clear?
Yeah.
Yeah. I will adjust. It's my job.
So if we're quizzing tomorrow, are we still doing like a Zoom call?
Oh yeah, oh yeah, oh yeah, oh yeah, oh yeah. So tomorrow, at the beginning, it will be regular class time. You know, so I answer your questions and I may introduce something new depending on the time, or I may not. It's not really a big deal. But tomorrow, regular class time, at the beginning, I will answer your question because I'm going to assign this stuff for tomorrow and this will be on your quiz. So you have to study it. You may ask me a question about it. I'll answer your questions. If time permit, I will start new material. If time will not permit, I will start the quiz. Does it answer your question? Any other?
Yes.
Now, Elizabeth
Yeah.
is asking me, would we be able to start 10 minutes early? What do you mean by that? The whole class or what? Elizabeth, you can speak up if you want.
I just meant like for the people who have 9 a.m.
Yeah,
commitments.
I have to think about that. I have to think about that. Yeah. Usually I let my student take extra time. That's during regular days. If you guys have work tomorrow at 9, I will have to adjust for it. All right?
So then our quizzes are timed.
Yes, they have to be. Yeah, I have.
How many questions is the quiz?
I have no idea. Ask me tonight at 2 o'clock in the morning. Any other questions? Anything else? Okay. On Brightspace, sorry, not Brightspace. On my lab, the questions along those lines, they are giving you multiple choice, you know, so, which is fine. But tomorrow you guys will have to do things by hand. Is that clear? So please, as you're practicing, do those problems by hand because there will be no multiple choice tomorrow. Tomorrow you will have basically to show me everything. So don't rely only on, you know, multiple choice. So when you do the problem, do it in the same details I'm trying to do them in class. That's how you're gonna learn. All right, because that's what I will be expecting from you tomorrow. There will be no multiple choice. So if I tell you find a formula, I'm not gonna give you 4 formulas, tell you pick the one that fits. I'm gonna give you the graph, you will have to find the formula, period. So you will not have a multiple choice tomorrow. Anything else? Okay, so if you have any personal questions, please, you can meet me in my office hours right after this class. And good luck. Bye-bye for now.